Welcome to the DIY Honda Garage channel. DTC P0615 pertains to a malfunction in the starter cut relay diagnosis circuit within the Honda Civic models manufactured between 2011 and 2015. This code indicates a specific failure in the circuitry related to the starter cut relay, which plays a critical role in the operation of the vehicle's starting system. The starter cut relay is located in the underhood fuse/relay box and is responsible for controlling the power to the starter motor, controlling when the engine can be started. When this circuit malfunctions, the engine may fail to start or may have intermittent starting issues. Understanding this code requires clear knowledge of the relay's functioning principles, the electronic control module, ECM, interactions, and effective troubleshooting steps. Before proceeding with diagnostics, it is crucial to review the general troubleshooting guidelines to ensure a systematic approach to identifying and rectifying the issue. The DTC P0615 indicates a malfunction in the starter cut relay diagnosis circuit. The starter cut relay is pivotal in managing the flow of electrical power to the starter motor. Its primary function is to act as a switch, controlling when the starter receives voltage, which is necessary for the engine ignition process. It is situated in the underhood fuse relay box, making it accessible for diagnostics and repairs. Additionally, this relay communicates with the electronic control module, ECM, which monitors various engine functions and calculates the required actions during starting. A malfunction could cause the car to fail to start because the circuit does not allow the necessary signals to pass through. It's crucial to isolate and diagnose this malfunction to restore normal function to the vehicle's starting system. The potential causes of DTC P0615 include a faulty starter cut relay, an open circuit in the diagnostic wiring, or poor electrical connections within the system. A faulty starter cut relay can prevent current from reaching the starter motor, therefore failing to engage the engine. An open circuit in the wiring could stem from degradation or damage, which interrupts the necessary electrical flow. Moreover, loose or corroded connections, particularly at the connections to the ECM, starter cut relay, or associated wiring harnesses, can lead to intermittent or complete failure of the ignition system. These issues often become apparent during components testing, making it essential to thoroughly inspect these areas during troubleshooting. Identifying the root cause is crucial for guaranteeing a reliable fix and preventing premature reoccurrence of the problem. Symptoms of DTC P0615 primarily include the engine failing to start and occasional intermittent starting issues. These symptoms indicate that the starter cut relay may not be functioning properly, leading to the disruption of the starting process. The vehicle's start-stop system may indicate a fault by illuminating a warning light or displaying DTC P0615 on the Honda Diagnostics System, HDS. Drivers may experience frustration from inconsistent starting, making it essential to diagnose and repair the underlying issue promptly. Additionally, the vehicle might have other symptoms depending on the severity of the malfunction and our ability to retrieve other DTCs that may accompany P0615. Timely identification of these symptoms can significantly reduce the potential for further complications related to the vehicle's electrical system. The first step in troubleshooting DTC P0615 involves verifying the problem using a systematic approach. Begin by pressing the engine start-stop button to power the system into the on mode, which primes the vehicle's electrical systems without starting the engine. Next, utilize the Honda Diagnostics System, HDS, to clear any existing diagnostic trouble codes, DTCs. This step ensures that you have a fresh start for monitoring any new codes that may arise during testing. Then, attempt to start the engine. After the attempt, check for any pending or confirmed DTCs using the HDS again. If DTC P0615 is present, this indicates that the failure has been duplicated and you should proceed to the next step in the troubleshooting guide. In the second step of troubleshooting, initiate another check for DTCs. Press the engine's start-stop button to select the on mode once again. This prepares the vehicle for another diagnostic session. Proceed to check for any pending or confirmed DTCs using the HDS diagnostic tool. Specifically, you want to determine if DTC P16F3 and P16F4 are indicated at the same time as DTC P0615. If they are, the troubleshooting for these additional codes must be performed as they may be interconnected with the starter cut relay circuit issue. If neither of these codes appears, continue to step 3 in the diagnostic process. Completing each of these checks ensures that all related fault codes are reviewed to give a full picture of the vehicle's starting circuit integrity. In the third troubleshooting step, it's important to confirm additional diagnostic codes. Start by pressing the engine's start-stop button to put the system back in the on mode. Following this, ensure that the clutch pedal is fully depressed, as this is critical for starting systems in vehicles equipped with manual transmissions. Once these conditions are met, perform a final check for any pending or confirmed DTCs using the HDS. In particular, you're looking to see if DTC P16F8 appears alongside DTC P0615. If present, this signals that further diagnostics for DTC P16F8 are necessary, as it may correlate with the issues at hand, thus affecting the overall evaluation of the starter cut relay circuit. If DTC P16F8 is absent, you're ready to move forward to step 4. The fourth troubleshooting step focuses on checking the related fuses, an essential part of any electrical system. Begin by pressing the engine's start-stop button to switch the vehicle off before proceeding. Next, locate and check the condition of fuse number A5, which is a 7.5 ampere fuse situated in the underhood fuse relay box. This fuse plays a crucial role in the operation of the starter cut relay circuitry. If the fuse is blown, replace it and investigate the circuit further for any signs of a short to ground, as this could indicate an underlying problem causing the fuse to fail. However, if the fuse is intact, then you can confidently move to step 5 in the diagnostic process, indicating that the fuse itself is not the cause of the starting issue. The final troubleshooting step involves checking for any open wiring issues which can impede circuit integrity. Start by removing starter cut relay 1 from the underhood fuse/relay box, creating an accessible test point. Next, utilize the HDS to jump the SCS line, preparing the circuit for continuity testing. Disengage the ECM connector A, which is a 49-pin connector, crucial for the electrical communication with the starter cut relay. With both the starter cut relay and ECM connector disconnected, check for continuity between the designated test points. Test point 1 at ECM connector A, number 24, green wire, and test point 2 at starter cut relay 1, 4P socket number 2. If continuity is confirmed, this indicates that the start diag/RLY 1 to 2 wiring is functioning properly. In such a case, consider updating the ECM software or substituting a known good ECM to eliminate software-related issues. If continuity is absent, this indicates a fault in the wiring, which must be repaired between the ECM and starter cut relay. Once all necessary repairs have been performed for DTC P0615, it is crucial to verify that the issues have been successfully resolved. Begin this process by clearing any diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This will remove historical codes from the system and allow for a fresh assessment of the current vehicle state. After clearing the codes, conduct a thorough test drive under various conditions to confirm that the vehicle operates correctly and the engine starts without issues. Monitoring for any DTCs that reappear during or after the test drive is essential. If DTC P0615 or any related codes return, further investigation may be required. This ensures that the integrity of the starting system, including the starter cut relay and associated components, has been restored. Preventive maintenance plays a significant role in avoiding recurring issues related to DTC P0615. Regular inspections of the starter cut relay and other related relays ensure they are functioning as intended and have no signs of wear or damage. In conjunction with this, routinely checking the condition of fuses, especially those linked to the starting circuit, helps to identify potential problems before they evolve into failures. Additionally, periodically inspecting electrical wiring connections for corrosion, looseness, or damage can prevent random failure points, thereby enhancing reliability. Regular maintenance checks can not only prolong the life of components, but also save substantial costs on repair. Keeping a well-documented history of inspections contributes to the awareness of the vehicle's health and open the doors to timely actions before symptoms develop. In conclusion, understanding DTC P0615 and its implications within the Honda Civic models can significantly aid in the effective resolution of starting issues. The steps taken to systematically troubleshoot the starter cut relay diagnosis circuit allow for a clear path to identifying and rectifying malfunctions. By following each diagnostic step meticulously, technicians can accurately target the root causes of starting difficulties. Furthermore, diligent preventive maintenance can avert many common electrical failures, thus enhancing the vehicle's overall reliability. It is paramount to address any DTCs promptly and perform comprehensive checks regularly. Knowledge and proactive management of potential issues all culminate in a better driving experience and a robust vehicle performance. Please like and subscribe to the channel. See you next time.